Hi and welcome to my maths class. Today we're going to do a rider that is working with the rule that states if two tangents come from the same point, then their distances are equal. Now let's look at the following. Okay, the first one says prove that AE is equal to EB. Now this is easy. If you've got that this is a center and this is a 90 degree, then you've got that AE is equal to EB because it is a chord that is perpendicular. Remember, you did that. That was your first rule that you did. Perpendicular to chord from center. Like the midpoint chord. You're given the 90 degrees, you're giving the center. So immediately I know that AE is equal to EB. Now how do we go to the second question that says AEC is congruent to BEC. Now in the two triangles, in triangle AEC and triangle BEC, we have that AE is equal to EB. That was calculated. Then we have that AC is equal to BC. Now that would be tangents, two tangents from same point. And last we have that EC is equal to, we have that EC is equal to EC, and the reason is it's common. Right. So immediately we can say that the two triangles are congruent because it's side, side, side. Now congruency is taught in grade 9. You need to be okay with your grade 9 work for these kind of theorems. They are not often asked, but they are very helpful. Now last, prove that AOBC is a cyclic quad. Now this is a clever question and it's asked very often. Now what do we know is a cyclic quad? A cyclic quad has two distinct rules. Number one, the opposite angles sum up to 180 degrees, and number two, the exterior angle is equal to the interior opposite. Now how are we going to apply this? If you look, they told us that AC is a tangent. We know that O is a center. So what can you tell me about OAC? Angle OAC is equal to 90 degrees. Tangent perpendicular to radius. And you can tell me the exact same thing about OBC. That it's equal to 90 degrees because it's tangent perpendicular to radius. But look, they are opposite angles of a cyclic quad. So if we take OAC plus OBC, it's going to equal to 180 degrees. But they are opposite angles of a cyclic quad. And since it's equal to 180 degrees, therefore AOBC is a cyclic quad. So when you want to prove something, then you have to take one of their rules and see is it applying. And in this case, the opposite angle is equal to 180 applied. And since it applied, then it is a cyclic quad. Thank you for watching.